So questions from the homework, page 380. Here's what I really think. First of all, there are two possible pathways. I can go up or down. I can go upwards or downwards. Remember what I said last day? What does the word or mean? It's going to be a plus sign. The upwards path, it looks like I have 3 choices and then 3 choices. Boom, boom. The downwards path, I have 3 choices and then 2 choices. Boom, boom. Total number of choices, 9 plus 6, 15. And now that I broke it up that way, you're like, oh, yeah. And a lot of these, the trick is getting you kick-started and then it falls apart. I will also say, though, Nicole, when you're done texting, as it turns out, it's very easy for me just to tweak a question and make it much, 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 much more difficult. Some of the questions that appear easy, I really find some of these questions somewhat counterintuitive. Any others from the homework? By the way, same thing for this third one. It'll be the top or the middle or the bottom, or means add. Figure out how many on the top, figure out how many in the middle, figure out how many in the bottom, add them up. Yes? 5 contains the letter P, this one here. Okay. We're doing 4-letter words. What's the restriction? It has to have the letter P. Whenever they give me a restriction, I always do it first. Did they tell me where it has to be? I'm going to set it by itself. I'm going to go, here's the P, and then 1, 2, 3 more blanks. This has to be a letter P. Just watch for a second, then I'll let you write it down. How many choices do I have for the first letter, for the P? Got to be there. Now I've picked it. Donk. How many choices do I have for the second letter? Right? 6. And I'm not allowed to repeat, so then there's 5, and then there's... Now that's the first step. However, it didn't say that the letter P had to be in the front. It just said that the letter P had to be anywhere. So the letter P could be in the first letter, or the second letter, or the third letter, or the fourth letter. How many choices for location do I have? 4 times 6 times 5 times 4. 4 choices for location, and then 6, 5, 4 for your letter combinations. Yep. Yep. We're here. Oh, you didn't get the notes. You watched the video lesson already? Or? Oh, cool. No, I like you again. 9D is both easy and tricky. Part of it is the wording. Excuse me. It says, how many different non-zero numerals? By non-zero, it's saying, please don't count 0 as a number. From here, non-zero, using some or all, I think what I'm saying, how many digits do I have grand total, Roxanne? I think I can make a 4-digit number, or a 3-digit number, or a 2-digit number, or a 1-digit number. You heard me say plus, write plus every time I said or? Okay, 1 digit is easy. I got 3 choices because I can't start with a 0. 2 digits, how many choices do I have for the first digit? Don't say 4 because I don't. 3 because I can't start with a 0. How many choices do I have for the second digit? Still 3 because the 0 is now back in play. 3 digits, 1, 2, 3. How many choices do I have for the first digit? 3. For the second digit, 3 again because the 0 is back in play. For the third digit, I can't repeat, so 2. See where we're going, by the way? 4 digits. 1, 2, 3, 4. I can't start with a 0, so I have 3 choices, but now the 0, Katie, is back in play, so I got 3 choices, then 2 choices, then 1 choice. Whatever the heck that is, I have no idea. Well, 18 plus 18 is 36, plus 9 is 45, plus 3, 48, I think is the answer. I hope. Woohoo! I can do math in my head. Does that make sense? Now that you see it, you're like, oh, yeah. Any others? Number 7. How many even 4-digit numbers have no repeated digits? This is what I said as an example of it's very easy for me to give you a simple sounding question that's much tougher. This is much tougher. And the reason it's much tougher is 0. For an even number to be even, can it end in a 0? Yes, but can I also, must I not start with 0? Because 0 belongs in two restrictions, this is going to lead me to the problem. There's two ways to do this. The easiest way is to find the total number of 4-digit numbers that don't repeat minus the odd numbers that don't repeat gives you the even numbers that don't repeat. Okay, that's one way to do it. Or because 0 appears in both restrictions, the other way to do it is to separate it like this. Ends in 0 or ends in 2, 4, 6, 8. 1, 2, 3, 4 has to end in 0, or 1, 2, 3, 4 has to end in 2, 4, 6, or 8. And I'll draw my little 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 grab bag. And the reason I have to do this is because the fact that 0 can sometimes be there and can't ever be there, because it appears in two different restricted locations, I've got to separate the cases. How many, let's end in a 0. How many ways are there to pick a 0? 1. Now there's no 0 left. How many choices do I have for the first number? Then. In the second case, I have to end in a 2, 4, 6, or 8. How many choices do I have? 0 is still in there. Let's suppose I picked an 8. How many choices do I have left? 0 is still in there. Don't say 9. Can I start with a 0? 8. Let's suppose I picked a 3. Okay, now 0 is back in play. How many choices do I have for the second digit? 8 again. Then. Okay, so that's one way of doing it. Or the other way was to say you have, here's all the numbers minus, here's the odd numbers. I have 9 to pick from because I can't pick 0. Now 0 is back in play. I got 9 again, then 8, then 7. I have to end in a 1, 3, not 4, Mr. Dueck. Nice try. 5, 7, or 9. I got 5 choices to pick from. I can't start with a 0, and I've already removed one number, so there's 8 to pick from. Now 0 is back in play, so all 8 are eligible. If you do that minus that will give you the same answer as doing it this way. That's a surprisingly difficult question because we can't start with 0 and even includes 0. Is that all right? Which one do you like better? I kind of like this one. I think it's cleaner. Or you like this one better? Really? Okay. The second one that I showed you, it's called finding the complement. Often you're going to find, Steph, it's easier to find what's not your answer and subtract from the total number of answers to find what is your answer. We're going to pull that trick out actually fairly often. For example, if I deal 5 cards and I say, what are the odds of getting 4 of a kind? I'll probably figure out what are the odds of getting all different and subtract from the total number. Whatever's left is 4 of a kind. Easier. Can I move the screen now? Yeah. Any others? Yeah. 11D. Okay. I guess we have, if we alternate, I'm pretty sure we have to have adult 1 there and adult 2 there. Do we not? Okay, how many choices do I have for adult 1? 2. How many choices for adult 2? And I can put a kid here. How many choices do I have for kid number 1? Then. In fact, it's kind of funny. The answer to D and the answer to B are identical because when you do B, you have to have adult 1 there and adult 2 there, so it's 2, 1, and then it's 3, 2, 1. It's actually the same numbers, isn't it? It's a 2, a 3, a 2, and a 1, a 2, a 3, a 2, and a 1. Is that all right? Yep. You want your calculators, specifically your graphing calculators, although a scientific one will work, but I'll have to find where the function is. But trust me, you're going to want to know where this is on your graphing calculator. Can you get out the notes that I gave you last day? The big stack of notes. If you don't have the big stack of notes here, sheepishly you can borrow a set of mine to follow along. But we're on lesson 2, permutations involving different objects. Lesson 2, permutations involving different objects. A permutation is a word. We're going to introduce what a permutation is. Investigate, it says, 2 letters, A and B, can be written in 2 different orders, AB and BA. These are the permutations of A and B. It's the number of different orders or arrangements you can mix them up in. List all the permutations of the letters A, B, and C. Okay. A, B, C, A, C, B, B, A, C, B, C, A. That's all the ones that begin with a B. What else can I begin with? C, A, B, C, B, A. I don't think I missed any. Did I miss any? How many permutations are there? 6. B says list all the permutations of 4 letters. Nuh-uh. That's enough. I said the whole theme here, Matthias, is we want to be able to count without actually counting. So what I want to ask is, how could I have gotten a 6 from that? Well, how many letters am I permutating? 3. Are you saying that maybe I could have drawn 3 blanks and said, how many choices do I have for the first letter? 3. Once I picked a letter, how many choices do I have for the next letter? 2. And then, does that work out to 6? Ah, there's a shortcut then, because there's no way I want to go A, B, C, D, A, B, D, C, A, C, D, B, A, C, B, D. Too many. That's just the ones that begin with an A. I think what I'm going to say is this. They want 4 letters? Okay. Nathaniel, how many choices do I have for my first letter? Then. What's the answer in your head without a calculator? Which would have been a pain to write out. Oh! How many permutations are there of 5 letters? What do you think the answer is? 1, 2, 3, 4, 5. Jessica, how many choices do I have for the first letter? Then. This is 20 times 12. 20 times 12, 240? No, 120. 120. 20 times 6, not 20 times 12. 120, yes? Phew. Now, we're going to fall back often as words because, Katie, we can often translate a problem into a set of letters or a word. You're going to hear me often say, hey, wait a minute, look. I'll write it out and I'll say, isn't that really a word? A weird-looking word, but a word. How many different ways can 5 people be arranged in a line? 120. I could call person A, person B, person C, person D, and person E. How many ways can 5 books be arranged on a shelf? I could call it book A, book B, book C, book D, book E. 120. It doesn't even have to be A, B, C, D, and E. How many different permutations are there of the letters in the word prove? Are all 5 letters different? Yeah, then you know what? 120. Let's go back to our word of A, B, C, D, E. But instead of picking all 5 letters, we could use fewer letters. For example, DB is a 2-letter permutation of these 5 letters, as is DE, as is DA, as is DC. as is AB, AC, AD, and AE, as is BA, BC, BD, and B. It says list them all. Forget it. I don't want to list them all. I want to just know how many there are. How many letters are we choosing? Amanda, how many letters are we choosing? How many blanks are we going to draw? Here's our Scrabble grab bag. Amanda, how many choices do I have for the first letter? Then, answer 20. Ah, yeah, makes sense. How many different three-letter permutations are there? 1, 2, 3. Steph, what do you think it's going to be? What times what times what? 20 times 3, 60. Okay. Example 1. When you press the scramble button on a CD player, when I was growing up, we used to listen to music on these things called CDs. They were these shiny circular objects, and they usually held about 15 or so songs. This one holds 5. If you hit this, but all of you have an iPod. I'm assuming all of you once or twice have used the scramble or the random feature. All that's doing is it's finding a permutation of the songs. I don't know if you've ever wondered, how many permutations are there on your iPod? We're going to start out small. How many permutations of 5 songs are possible? How many permutations are there of the word compute? Did they say they want me to pick 2 letters, Sabrina, or 3 letters, or is it just how many, which means pick all of them? How many letters are there grand total? 7. Are they all different? Because, by the way, Wednesday's lesson is what if you have the same letter appearing twice? Very easy. We tweak what today's lesson. Are they all different? What is 7 times 6 times 5 times 4 times 3 times 2 times 1? 5,040? Mr. Dueck? Yes, Cassandra. I've noticed in a lot of these, we're starting with a number and going down by 1, going down by 1, going down by 1, stopping when we get to 1. Starting, going down, 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 stopping when we get to 1. What if it was a 10-letter word? You would go 10 times 9 times. Yeah, Mr. Dueck, it would be very nice if there was something like this built into our calculator. Well, there is. It's called factorial notation. The symbol for factorial is an exclamation mark. You do not read this as 1! You read this as 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, and 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. By the way, once you've written that down, let me show you another way to think about this. Five factorial is really 5 times 4 factorial, isn't it? Look. Because wasn't 4 factorial 4 times 3 times 2 times 1? Then 5 factorial is really 5 times 4 factorial. 4 factorial is really 4 times 3 factorial. Sometimes that little trick might come in handy, especially if I just give you one more letter and you don't feel like retyping everything. You might say, oh, I already did 3 factorial and they're giving me one more letter. I'm not going to go to my calculator. I'm just going to multiply my answer by 4. It's 4 factorial. N factorial. So here's the generic definition. It's n times n minus 1 times n minus 2 times times 2 times 1. The definition of factorial is start with the number that they give you, multiply it by 1 less times 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 1 less. Stop when you get to times 2 times 1. And this is on your calculator somewhere. Steph's trying to figure out where. All of you get your graphing calculators out, please. And the one I'm interested in is example 2. Got over here, by the way, can we write over here, this is really 7 factorial, yes? How would we find that on our calculator? We would type 7. And then are you ready? It's in your math features right here, the math button. And although it's under the probability menu, which is arrow right 3 times, it's faster to go left arrow once because that also gets you there. Yeah, I mean, you can go right, but it's much faster to go left arrow, and you'll want shortcuts, believe me. See it, Trevor? What number? Right now, please, what's 10 factorial? Okay, play a little game. I'm curious to see how big these numbers get. Can you go 20 factorial? I think you get an answer in scientific notation, yes or not? But you do get an answer, yes? How about 50 factorial? Does that work? Yeah? How about 75 factorial? Does that work? No? How about 65 factorial? Does that work? How about 70 factorial? No? How about 69 factorial? So sadly right now, because our calculator can only handle 99 digits, which you thought was a lot, as it turns out, we can't deal with more than 69 objects. Now, thankfully, there's 52 cards in a deck, so we can deal with decks of cards. But if you ask me to do a permutation of the number of days of the year, I can't do it on the graphing calculators as is, because there's 365 days. In fact, there are plenty of groups that are larger than 70. 70 is the cutoff. That's where your calculator crashes. There are plenty of groups that are larger than that. So you may have thought that some of these numbers were not all that useful. Actually, do you want me to find out how many different ways that I can rearrange 70 objects? My calculator can't do it yet. I need to go to some other piece of software. And 70 is not that big. So how many of you have more than 70 songs on your MP3 players? Sorry, I lied to you earlier when I said, have you ever wondered how many permutations there are of the songs on your MP3 player? The answer is, you got more than 70, sorry, can't do it. Wolfram Alpha might be able to. I don't know. Or there might be a website with some software. So that's factorial notation. We're going to start to use that as a shortcut in a second. Now, example 3 says this. How many 3-letter permutations can be formed using the letters of the word compute? Are we picking all 7 letters? Nope. So how many choices do we have for the first one? Still 7. Then what? 6. Then 5. But we're not going to use the 4, 3, 2, 1. Isn't this... Now let me convince you. Wouldn't this be 7? Write this out, please. 6, 5, 4, 3, 2, 1. 4, 3, 2, 1. Can I cancel the 4, 3, 2, 1? Is it factored? Oh, what did the exclamation mark stand for? Factorial. Oh, no, it is factored. Does that give you 765? Yeah. This is going to give us a shortcut as well, because we're going to say this. How many letters were there grand total, Sabrina? How many letters was I picking? What number did I put down here? Can you find a way using a 7 and a 3 to get a 4? How can you get a 4 from a 7 and a 3? So we're going to come up with a permutation formula, and it's going to be the total number of letters divided by the total number minus how many you're picking. Patience, but that's what's coming up. In fact, we write it this way. Turn the page. We use a capital letter P for permutation. From 7 objects, permutate 3 of them, and that's going to be 7 factorial all over 7 minus 3 factorial. Except, Sabrina, what was 7 minus 3? 4. By the way, what is 7 times 6 times 5? Well, 6 times 5 is 30 times 7. Turn back one page and go 210. Or you can write it here, 210. Okay. As a formula, here's what we say. If you have n objects, lowercase n, and you're permutating them r objects at a time. Hey, from 7 letters, pick 3 of them. From 12 letters, pick 5 of them. From 8 letters, pick 2 of them. This is going to be n factorial all over n minus r factorial. See it kind of popping out of there? Yes? This is on your formula sheet. You don't need to memorize it, but you will need to use it. So, permutations, it says this. An ordered arrangement of distinct objects is called a permutation. The number of permutations of n distinct objects was just n factorial. That's if you're picking all of them. If you're not picking all of them, if you're only picking r of them, n p r, which is n factorial all over n minus r factorial. So, how many 5-letter arrangements can be made from A, B, C, D, E, F, G, H, I, J? 10 letters. I would go like, don't write this down. You can if you want to, but just watch. How many 5-letter arrangements can be made from A, B, C, D, E, F, G? It is 10. 1, 2, 3, 4, 5, 6, yeah, 10 letters. It is 10 times 9 times 8 times 7 times 6 if I use the fundamental counting principle, because I could say, hey, 1, 2, 3, 4, 5 letters. Or, what's that? What is 10 factorial divided by 5 factorial? Amanda? 30,240. Someone else want to double check? Yeah? Okay. How many 7-letter arrangements? I would write this as, From 10 letters, permutate 7. It's going to be 10 factorial all over 10 minus 7, or 3 factorial. Or 10, 9, 8, 7, 6, 5, 4. Is that 7 letters? Yep. What is 10 factorial divided by 3 factorial? Can someone do that on their calculator? 604 800. Mr. Dueck? Yes, Amanda. It'd be kind of nice if our calculators had this built in. Yeah, it would, wouldn't it? Type 10. Math. Left arrow. Is there an NPR that appears anywhere there? Oh, what number is this one? 2. How many objects am I permutating? How many am I picking? 7. Does that also give you 604,800? So you have it built in. There's your shortcut. So, just for fun, how many 4-letter arrangements? Well, that would be 10p4. What is 10p4? Find it. Psst, hey. Look, 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 look. Second function, enter, backspace, 4. Ah. Or you can go 10, math, left arrow, option 2, 4. 5,040. Okay. But what does this mean? This means 10 factorial over 6 factorial. It means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom is a 6 times 5 times 4 times 3 times 2 times 1. So the 6s and the 5s and the 4s and the 3s and the 2s and the 1s cancel. Example 4. Example 4 says, write each expression without using the factorial symbol. Say, what? Well, if I give you NP2, what that means is the first number, factorial, divided by first minus second number, factorial. Now, what is n factorial? I'm going to ask you on your test, I guarantee it, and on your quizzes, I guarantee it, to simplify some kind of algebraic factorial expression. And the way I simplify these is I ask myself always, which is bigger, n or n minus 2? Which one's bigger, n or n minus 2? N would have to be bigger than 2 less than n. I start to expand the bigger one. What I mean by that is I'm going to start to rewrite this slowly without the factorial symbol. I'm going to rewrite the bottom one. The top, n factorial, Tyson, what that really means is n times n minus 1 times n minus 2 times n minus 3 times, except, let me say this again, n times n minus 1 times n minus 2, put your pencils down, please. I could write n minus 3, n minus 4, n minus 5, n minus 5, but isn't that really n minus 2 factorial? Because that's this times 1 less times 1 less times 1 less times 1 less. Now, Steph, why did I stop there? What do I have on the bottom here? Can I cancel? Are they factored? Do you know what this simplifies into? Pick your pencils up. That whole thing apparently simplifies to n squared minus n. These are tricky. Here's another factorial expression to simplify. What's bigger, n plus 2 or n minus 1? Holly. I'm going to start to expand that, and I'm going to stop when suddenly I get to n minus 1. Then I'm going to quit and say I'll replace the rest of them with a factorial expression. You ready? The first term is n plus 2. What's 1 less than n plus 2, Holly? What's 1 less than n plus 1? Careful. N plus 0 or just plain old? No. N. What's 1 less than n? Oh, is that what I had on the bottom? I could keep going, but I can replace the rest of them with that. Rewrite the bottom now. Holly, can I cancel? Is it factored? It is. You know what that mess simplifies into? That mess simplifies into n times n plus 1 times n plus 2. There's an n plus 1 and n plus 2. I could FOIL that out if they wanted me to. I'm not going to bother. Unless I look at the answers and notice that they have. C. C. It says n factorial times n plus 1 factorial all over n minus 1 factorial, n plus 2 factorial. How many terms are there? How many terms on the top? Meant to be easy. 2. How many on the bottom? I'm going to mentally kind of divide this in half. Mentally, I'm kind of going to go yoink. I'm not going to draw that though, but I'm going to kind of put the first term over the first term, the second term over the second term. Looking at these two, what's bigger, n or n minus 1? N is. I'm going to start to expand it. I'm going to say if I want to get rid of the factorial, if I want to expand it, that's n times, Roxanne, what's 1 less than n? Say it louder, you're right. 1 less than n. Is that what I had on the bottom, Roxanne? Then, okay, I'm going to stop there. I could keep going if I needed to, but I'm going to stop there. Now I'm going to look at the next two terms. Amanda, which one's bigger, n plus 1 or n plus 2? I'm going to start to expand that. So there's going to be an n plus 2. What's 1 less than n plus 2? Is that what I had on the top? Then I'm going to replace the rest, instead of continuing to expand, I'm going to replace the rest of the terms with a factorial. Can I cancel? They are factored. Can I cancel? They are factored. What's left behind? This whole thing simplifies to an n on the top and an n plus 2 on the bottom. These take some practice. You'll get some in your homework to practice. Turn the page. We're going to come back to these. Keep this handy, but can you open your workbook, please? To page 383. Page 383. Page 383. So here is an explanation of factorial notation. It says 6 factorial, you can figure it out. 9 factorial, you can figure it out. To simplify a quantity like a factorial over a factorial, there are a variety of approaches. You can do it on your calculator, or you can realize that you can go by cancellation. 10 factorial is 10 times 9 times, like 10 times 1 less times 1 less times. Oh my goodness, the bottom term just appeared. Stop, replace the rest of them with a factorial symbol and cancel. For example, this is really 43 times 42 times 41. Because the next thing that I would write would be what? A 40 and a 39 and a 38, and those would cancel with that 40 and 39 and 38 and 47. Okay. This is really, well, there is a 4 factorial on the bottom. But with this 37 and this 33, it's really 37 times 36 times 35 times 34, and I could quit there, times 35, Mr. Dueck. You wrote 36 twice like a meathead. 1 less times 1 less times 1 less times, what would the next number that I would write here, Amanda, be? 33, and then, you know what, I can replace that 33, 32, 31, 30 with a 33 factorial, and that would cancel the 33 factorial on the bottom. This would be easier to type into my calculator, way less work. Perhaps. Or if I had to do it in my head, perhaps. Algebraic ones, we already did A in our notes. B. Which one's bigger, the top or the bottom? What's bigger, n plus 3 or n? Start expanding that. So you ready, Matthias? The first term would be n plus 3. What's 1 less than n plus 3? Yep. And I'm going to keep going. You know what? I'm going to stop when suddenly an n appears. What's 1 less than n plus 2? I agree. What's 1 less than n plus 1? Ah! And then I could keep going, or I could say, you know what? If I stop here, because I had that on the bottom. Matthias, can I cancel? Because it is factored. This works out to n plus 3 times n plus 2 times n plus 1, which I could FOIL out if they wanted me to, but I'm not going to bother. Okay. Turn the page. Permutations, example 3. How many different permutations are there of the letters in the word Regina? Are all the letters different? Yes? 1, 2, 3, 4, 5, 6 letters. Which is what? Evaluate it, please. What is 6 factorial? I think 720, but don't quote me on that. Is it? How many permutations are there of the word Kelowna? How many letters are there in the word Kelowna? 7? Are they all different? 7 factorial, which is 5040. Here is your NPR formula, your permutation formula. So, example 5. In a South American country, vehicle license plates consist of any 2 different letters followed by 4 different digits. Find how many different license plates are possible by, okay, we can use the fundamental counting principle. Letter 1, letter 2, number 1, number 2, number 3. We could do it this way from last day's lesson. How many choices do I have for the first letter, Ryan? No, I'm picking 2 letters, but how many choices do I have? 26. And then it says they have to be different, so how many choices do I have for the second letter? And then how many choices do I have for the first digit? Then? Can you type that into your calculator? What do you get? Oh, 1 more digit? I'm sorry. What is 26 times 25 times 10 times 9 times 8 times 7? Sorry? 3,276,000. Oh, that's wrong there. 3276 and 3 zeros, is that right? So you could also have done this with permutations. You could have said from 26 letters, permutate 2 of them, times from 10 numbers, permutate 4 of them. Type that into your calculator. What do you get? Same answer? Same answer. You could have done it with permutations. I'm more comfy with drawing a blank, but I'll use this as a shortcut once in a while. Okay. Back to our notes here. The other thing I'll give you on your test is some kind of algebraic combinatorics equation like this one. A says solve each equation for x. xp2 equals 42. Now, did you all just turn the page? This is at the top of a new page. Then at the top right here, can you write npr equals n factorial all over n minus r factorial. This was the factorial equation, the factorial formula, permutation formula. So when they say xp2, Tyson, what's sitting where the n is? What's sitting where the r is? So I can rewrite this as x factorial all over x minus 2 factorial equals 42. You could do that. Problem is there is no mathematical operations designed to deal with factorials. I have to somehow get rid of them. And I can. You know how, Steph? What's bigger, x or x minus 2? Start to expand that as x times x minus 1 times, oops, I'm going to stop here, x minus 2, because that's what I have on the bottom that I would like to cancel out. Why is that handy? Steph, can I cancel? Because it's factored. And you notice I'm canceling out a factorial term. I'm getting rid of the factorial, which means now I have an equation I can solve. In fact, now the equation that I have is this. What kind of an equation is this? It's quadratic. How do I know? Because when I get rid of brackets, what will I have? Let's do that. This is going to be x squared minus x, and can I minus the 42 over to make it equal to 0 right away? How do I solve this factor? How? Oh, not a GCF, but there's no leading coefficient. These were the easier ones. I'm looking for two numbers that multiply to negative 42 and add to negative 1. What are the roots? Not quite done. Can I have negative 6 letters to pick from? Nope. Can't do a negative factorial. negative 6. Error. Can't do a negative factorial because, Katie, you can't have negative 8 letters to pick from. Doesn't make sense. Okay. I like that question. I like that question. I like that question. I like that question. Now, I used to cover B just in case it ever showed up on the provincial exam. Since there isn't one this year, I'm going to nuke B, but we are going to do C together. X permutate 2 equals 110. I think what this really means is x factorial all over x minus 2 factorial equals 110. I can't cross multiply right now or anything like that because there's nothing that I can deal with, that I can do to deal with the factorials. I want to leave the factorials on the same side, and instead I'd like to get them to cancel by asking myself, what's bigger, x or x minus 2, Jessica? I'll start to expand that. This is going to be x times x minus 1 times x minus 2. Oh, I'm going to stop there because that's what I have on the bottom over here. And then I can cancel. I end up with x times x minus 1 equals 110. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. Not yet, but it does. In fact, Amanda, when I multiply this out, I think I'll get x squared minus x, and then when I make it equal to 0, I think I'll have a minus 110 equals 0. I'm looking for two numbers that multiply to negative 110 and add to negative 1. I think 11 and 10, yeah? One positive, one negative. I mean, there's not much that goes into 110. It's either 5, 2, 11, or 10. I mean, I can try my 10 times table first. I think we get x minus 11, x plus 10 equals 0. The roots are positive 11 and negative 10. Reject the negative because you can't have negative 10 letters to pick from. So there's going to be some kind of a quadratic trig combinatorics equation on your test to solve on the written section. Guarantee it. By the way, on your calculator, what is 0 factorial? Cassandra. Now this bugs people because this does not fit the definition. It's defined as 1. Because remember, we said 3 factorial was 3 times 2 times 1. 0 factorial should be 0 times some, but isn't anything times 0, 0? How do you get a 1? And the answer is, we had to define it that way. It's, your calculator knows that when you type in a 0 factorial, 1, because mathematicians define it that way. The real question isn't, why? I'll show you. If you pick 5 objects, 5 at a time, you can get this in 2 ways. You can go 1, 2, 3, 4, 5 blanks, 5, 4, 3, 2, 1. Right? 5 letters and 4 letters and 3 letters and 2 letters and 1 letter. What is 5 times 4 times 3 times 2 times 1? 120? I know that there are 120 permutations if I have 5 letters and I pick all 5 of them. But if I plug this into the permutation formula, I get this. 5 factorial all over 5 minus 5 factorial. Right? Steph, what's 5 take away 5? This is 5 factorial, take away 0 factorial. Now, by the way, this 120, Steph, is 5 factorial, and these both have to be the same answer. The only way to get the same answer is if 0 factorial works out to the same thing that's on the bottom right here. What is on the bottom right here? It's invisible. It's an invisible 1. That's got to work out to, that has to, that must, otherwise we got a problem and have an inconsistency. It must work out to a 1. So it's defined as uno, 1. It doesn't fit the rest of the factorial. Perfect. Back to the workbook. So here's your defining 0 factorial that we just did in our notes. Homework. Number 1, 2, 3, 5A, B, and C. For B, divide the n minus 1 factorial over to this side. Six, 9, 'll pause there. Okay.